Hello. Today we're going to look at surface area for prisms and how it changes when you change the dimension of one of the three dimensions. So we're going to look at the effects on the total surface area when you double the length, the width, or the height. Please follow along by turning to page 83. I want to explain to you how 83 will work. We have our slide that looks just like this one, and that's the one on the top left. You're going to show your work for our original prisms, the calculations for that, where it says number 1. Number 2, we're going to show how the surface area is affected when we change the length. And then number 3, we're going to show, that's at the bottom half on the left, show how the surface area is affected when we change the width. And then number 4, if you'll follow along on page 83, bottom left, there's a space for you to show how the surface area is affected when we change the height. And then I'm going to ask you to give me a brief explanation as to how the surface area is affected when we change one of the three dimensions, and see if you can find any connections. Okay, so let's start with our original prism. And our original prism has a length that is 3, a width that is 4, and a height that is 2 units. So when we use our formula, go ahead and jot this in on the top right. Surface area is equal to 2 times the length times the width plus 2 times the length times the height plus 2 times the width times the height. And we've talked about this quite a bit, but the reason we're doubling the length and the width is because the length and the width will give us the top of that rectangular prism. Since the bottom is parallel and congruent to it, we can just double it. So we'll take that product, add it to 2 times the length times the height, which will give us the front and the back, 2 times the width times the height, which will give us that left side and that right side that are also parallel and congruent to each other. So here are our substitutions when we plug those values into our formula. Please hit pause here and find this calculation before you go forward to find the total surface area. Our total surface area for this original prism is 52 square units. So now we're going to look and see what happens when we double the length. So originally the length is 3 units. When you double it, you get a length that is 6 units. We're going to see, what do you think will happen? Do you think the surface area is going to double with us doubling the length? Let's see. So our formula is the same. Our substitutions look a little different because where our length originally was 3, now it's 6. Please press pause. Go ahead and do that calculation. Thank you. Okay, when you double the length, you should have gotten a new surface area that is 88 square units. Want to point out that though we doubled one dimension, there's not a doubling effect with the total surface area. 52 doubled would be 104. We don't have quite that much. Let's see what happens when you double the width. Do you think we'll get a value equal to 88? Let's see. So the width was originally 4 units. We're going to double it and make it 8 units. Notice that where we plugged 4 into our formula, now we're plugging in an 8. We changed the length back to its original measure. Plugging in an 8 here as well. Please hit pause and go ahead and find that total surface area when we double the width. Okay, you should have gotten a total surface area of 92 square units. Interesting, because it's not the same as 88. I wonder if it has something to do with the sheer size of the new length and the width. I wonder if that's why it's larger. So maybe think about that. And as we double the height, try to make some estimations or form some ideas about what our new surface area is going to be when we double the height. So our formula is the same. Our substitutions look a little different because where the height was 2, now it's 4. Notice I changed the length and the width back to their original amounts. Please hit pause and find the new surface area. You should have gotten a new surface area of 80 square units. Notice that it's larger than the original, but smaller than the other two changes. So now please take some time and in that last space, it asks you to do the following. It says, based on the three findings, explain how changing the one attribute, that's referring to the length, the width, or the height, affects the total surface area. So please press pause and take a few moments to do that. And this is just one explanation. And really there is no specific pattern on the effective surface area of the change in one of the attributes. The reason there is no pattern is that the change in one attribute affects the two of the three terms in the formula. But I would also say that perhaps there is a slight correlation in that if the more effect you have on one dimension, and I'm going to go back and look at the entire screen, there's more space between 3 and 6 than there is between 2 and 4. And of course 4 and 8 have there's the most change between those two values, therefore the surface area is going to show the most change. So I think that is perhaps the better explanation because there is a slight correlation between the total surface area and the effect of changing just one of the three dimensions. So what I would like you to do now is turn in your books to page 85. And on page 85, there are 5 questions to answer on your own. And read them carefully. It's going to ask you to double or cut in half one of the three dimensions and find the new surface area and talk about how the old surface area and the new surface area are related.